Hello everybody, I'm Federico Pintore and I'm going to present Calamari and Falafl, logarithmic linkable ring signatures from Isogenies and Lattices, which is a joint work with Ward Beulens and Shuichi Katsumata. Ring signatures allow a signer to produce a signature on behalf of a group of users, called ring, and the signature hides the real identity of the signer. They were introduced in 2001 by Rives, Shamir and Tauman, who motivated them as a means to protect whistleblowers. Ring signatures have recently found other practical applications in electronic voting systems and in cryptocurrencies. Recently, cryptocurrencies providing privacy by default have been proposed. Among them, we can mention Dash, Monero, and Zcash. Monero uses ring signatures to achieve privacy. Unfortunately, the security of the ring signatures used in Monero relies on the hardness of the discrete logarithm problem, which can be solved in quantum polynomial time. Given the threat represented by the realization of quantum computers, there's the need to identify quantum-resistant replacements. Calamari and Falafl are two new ring signature schemes from post-quantum assumptions. They are instantiations of a new, simple and efficient generic construction of all proofs for a class of group actions that we called admissible group actions. Admissible group actions are group actions required to satisfy some general properties that capture different cryptographic frameworks. We instantiate the admissible group action both with isogeny assumptions obtaining Calamari and with lattice assumptions obtaining Falafl. The reason for designing a new OR proof is that OR proofs can be converted into ring signature schemes. In our case, the ring signatures have sites which depends logarithmically on the number of signers n. The factor multiplying log of n is just a constant c which depends on the security parameter, times the output length of a hash function. Therefore, the dependence on log of n is very mild, and our signatures scale better than previous post-quantum ring signatures. Calamari is the instantiation with isogeny assumptions, and it is the first isogeny-based privacy-preserving signature scheme. It produces the smallest signatures among post-quantum alternatives. Falafel is the instantiation with lattice assumptions. Signing is much faster than Calamari, and from n approximately 1024, the size of the signatures produced by Falafel are smaller than any other lattice-based ring signature. The OR proofs we proposed are actually two. One leads to ring signatures, the other to linkable ring signatures. Since they rely on the same general idea, in the following I'll focus just on the first one. Post-quantum ring signatures having signature sites which scales logarithmically in n have been proposed only from symmetric key primitives and lattice-based assumptions. In terms of signature sites, the state of the art for symmetric key primitives is the scheme by Katz, Kolesnikov and Wang, KKW in the graph. As you can see, the signatures produced with Calamari and Falafl have sizes that are smaller than those produced with KKW, due to the better multiplicative factor of log of n. The state of the art for lattice assumptions is the ring signature by Esgin, Zhao, Steinfeld, Liu and Liu, EZSLL in the graph. For a fair comparison, for Falafel we consider the signature sites for a parameter set that achieves NIST security level 2. Falafel for 2 in the graph. From n approximately 2 to the 10, the size of the signatures produced with Falafel is smaller than the size of EZSLL signatures, again because the multiplicative factor of log of n is smaller. In terms of efficiency, for post-quantum ring signatures, the state of the art is the lattice-based scheme Raptor. Falafel has similar performances compared to it, but Raptor produces signatures of size that scales linearly in n, and from n equal to 2 to the 5, the signatures of falafel are shorter. In the following, I'll recall what an OR proof is, and I'll give the definition of admissible group actions. Then I'm going to present the new OR proof, and finally I'll give a few details about Calamari and Falafl.